Hi, I'm Carl Franklin. In episode 66 of Blazor Train, I introduced C# async streaming using iasync enumerable in SignalR. In this episode, I'll compare two other ways to stream data from a server to a Blazor client. One is using a REST API endpoint, and the other using gRPC. Remember that streaming isn't about using system I/O streams. It's about using yield return and iasync enumerable. Streaming is also not about performance. It's about scalability. If you're not familiar with the basics of streaming, go back and watch episode 66. Now, you might want to move out of the quiet car, because by the end of this episode, you'll be cheering, "Viva la stream!" And that's all coming up right now, right here on Blazor Train! All right, so I'm starting with the sample code from episode 45, Web API versus gRPC. This is where we compared performance of Web API versus gRPC using a very large set of simple objects, a list of person objects that were created on the server from a JSON file. And it wasn't really about the complexity of the data, it was about the number of records. And so what we did in that episode was compared downloading 5,000 records, and I know you'd never do that in the real world, would you? No, you wouldn't. 5,000 records from a server, an API server, and also a server that does gRPC, to a Blazor WebAssembly client. Now, that client was written in .NET 5, so the first thing we're going to do is upgrade this to .NET 6. And I've showed you this before, how easy it is, but we'll do it one more time just to be sure. The first thing we're going to do is change this .NET 5 to .NET 6, but we're going to add a couple settings here too. And then we're going to upgrade basically these Microsoft ASP.NET Core components WebAssembly from 5 to 6. So let me just do that now. And here you go. So target framework is now .NET 6.0. We have nullable enabled just because I want to be, using the defaults and in the fold of what's happening. And also implicit usings, which means I don't have to litter my project with usings everywhere that I always use. Also note that I'm using Newtonsoft JSON rather than system text JSON in this project. I just find Newtonsoft JSON to be, well, it works better. Okay, there, I said it. So the best thing to do is once you change your target framework to 6, just go ahead and upgrade the NuGet packages, and all of these things will be updated. All right, so I'm going to also do that for the server project and the shared project. Now the shared project, I'm going to bring this guy down here, get him out of the way, because these are the things that I'm going to change. There. Now I want to also change the startup stuff. So in the server, we're going to remove startup CS. Just go ahead and delete it. And we're going to change the program to use the new .NET 6 minimal version. All right, let's also change the client program CS to be less verbose and do things the .NET 6 way. There we go. Now you notice I've got global usings here. Global usings are good. And the reason I only have usings for the ASP.NET Core components is because this is the only place that I use them. All right, now I told you I was using Newtonsoft JSON for this project, whereas the old one used system text JSON. So let's upgrade API service in the client to use Newtonsoft JSON. Now I left this using Newtonsoft JSON statement in here because I want it to be very clear that we're not using system text JSON, we're using Newtonsoft now. And pretty much it's the same stuff except using JSON convert deserialize object. All right, now just to make sure that everything's working before we add anything new, let's run this and see if the .NET 6 version holds up to the .NET 5 version. All right, so this grabs 5,000 records from the REST API endpoint, and it comes in at 2.1 seconds. Now, the first time we hit that endpoint, the manager has to load the data, so the second time it's going to be faster. Not only faster because the data is loaded, but also because it's now compiled and ready to go. So yeah, 1.6 seconds, something like that. All right, now we'll test gRPC. Comes in at half a second. We'll do it again, 325 milliseconds. And this is on par with what I got in episode 45. But remember, streaming isn't about performance, but just to show you the difference between REST APIs and gRPC, that's a significant performance increase. And then we also have this getRandomPerson thing, which we're not going to use today. All right. Now that everything works and we're satisfied, let's start by adding a streaming endpoint to the REST API. So I'm going to go to the persons controller, and I'm actually going to replace this getAll right here. I'm going to take that out, and I'm going to add 2 new endpoints. And here's why I replaced getAll. It's this. I've got to name these differently because they don't take any parameters, and they're both HTTP GET. And I found that if I didn't add a parameter here, or I didn't name them, then the HTTP client doesn't know what to do. So I've named this one GET, and this one GetStream. So let's look at GetStream in detail. So if you saw episode 66, this should be familiar to you. But it's so easy, right? We have a public async endpoint that returns an async enumerable of person. So async means that it is a task, it's a value task. That's why I don't have to have a task of async enumerable. And it's also an enumerable. So it's an async enumerable. And it's this is brilliant from C#8. This is where this was introduced. And we don't take any arguments. I'm doing a little await right here to appease the compiler because we got to do something with await. But in the real world, the reality is that you're probably using await to get your data from your database, right? We're not. We're just grabbing it from our persons manager. And this is just a list. So we're going through each person in the list and using yield return. And yield return returns this person immediately to the caller. So as we're going through 5,000 records, we are streaming these guys out one at a time to the caller. That's what streaming is. All right, now let's add support code to API service so that we can call this endpoint. Now I have to change this as well. All right, so my getAll, the only difference is this right here, the URL. The request is now persons/get. Because remember, I changed it from no name, which was just persons, to persons/get. Now, this is the pattern I'm using for retrieving an async enumerable from an API endpoint and returning the async enumerable to the caller one record at a time using yield return. So remember, I'm using Newtonsoft JSON. So this is a Newtonsoft JSON serializer. And I'm returning HTTP, my HTTP client, getStream async. So this returns a stream. It's just a simple system IO stream. And remember I said it had nothing to do with streams? Okay. In this case, it does, but that's not what streaming is, right? Streaming isn't just using a system IO memory stream or other stream. So I'm going to now create a stream reader. Now this is a system IO stream reader. So we're still within the realm of .NET here, the .NET framework. And now I'm creating a Newtonsoft JSON text reader from the stream reader. And the JSON text reader treats a JSON string as a series of tokens, which are read one at a time. And I have a nice URL for you to follow here in the source code if you want to learn more about JSON tokens. So I'm going to read each item in a loop with read async. And now I'm going to ignore the start and end tokens. So there's a token type enumeration. And so all I'm doing here is making sure that the token type isn't either the start or the end of the array. So now I'm deserializing this item returned through the reader as a person and using yield return to return it. When I call this stream, I'm calling an iasync enumerable, which is going to use yield return right here. And on the client, I'm going to use yield return to return to my caller. Think of it this way. Each record comes out of the database through the API endpoint to this code, which returns it to my UI. Boom. That's a stream. All right, now on the gRPC side, it's a little bit different. First of all, let's go to our proto file. And this is our people service. And I'm just going to add this. GetAllStream is the name of this particular service endpoint. And look at this. I'm using the same getAllPeople request, but instead of returning a single person, we're returning stream person. So interesting, we don't have to create a special array type or a special list type or anything like that in order to do streaming. It's built into gRPC. So I just say, I want to stream person objects, and here's my endpoint. GetAllStream. That's it. That's all I have to do to my proto file. All right, so let's go to our people service now, and we're going to add GetAllStream. Okay, so here's the pattern. We have our request as a parameter. We have an iServer stream writer, which is called response stream. You can call it whatever you want, but that makes sense. And then the server call context. And also note that it's a virtual method. The base stuff has already been done for us. All we have to do is override this. Now, rather than returning something, we're going to write to response stream, and it's very simple. We retrieve our list, and we write each item to the response stream, and response stream does the rest. Every time we write to a stream, it goes back down to the client. All right, now let's update our UI pages. Starting with index. And I said pages because we're going to add another page after this one. So this index, remember, is just about measuring how long it takes to get data. And I wanted to include this because the results may surprise you. So now I have 4 buttons. And you know what? I'm just going to run it. And then we'll look at the code. Now, this is really a performance test, isn't it? So let's start with the API. 2198 is probably going to be faster the second time. All right, now let's see how long it takes to retrieve those same 5,000 records if they're streamed. Interesting, huh? Look at that. It's taking longer. Now you might be thinking, why would I do streaming if it's going to degrade performance? Well, that's a great question. You just keep that question in the back of your mind, okay? I'll be around to punch your ticket in a minute. Know what I'm saying? So what about gRPC? All right, so we know that very high performance, 273 milliseconds. Now let's test the gRPC stream. Performance is significantly degraded here. Okay, now let's look at the code. This API button clicked for the first button to test downloading all of the people from the API. It's the same code as it was before. I've just added a few comments. We get all, we get the elapsed time, we show the elapsed time. Now here's the stream button clicked. So we're using await for each. Await for each is used on an iasync enumerable which returns one item at a time. So we're adding that person one at a time to the list and then checking the elapsed time. We're going to use this again. Just hold on. Now the gRPC. So if we're going to download all the people from gRPC service, this is what we did before. We get the response, and if it's not null, response contains this people. It's not really a collection. It's a repeated field. That's what gRPC calls it, so it's not a list. But we can call toList on it to get our list back. Now, gRPC streaming. The first thing we do is call people client get all stream, passing the request. And that returns an async server streaming call. All right, so this doesn't contain the data. You have to iterate over the response stream within that call using move next. And we've just got a new cancellation token. And then we're adding response stream current as a person to the list and showing the elapsed time. So that's performance. Remember I said it's not about performance, it's about scalability. Let us take over the counter page now. Now this is a select or a list box that I've set to show the first 20 items. Now what I do when I stream in both the gRPC and the API is I'm getting these one at a time. And on the 20th one, I'm going to update the UI so that you see the first 20 right away. And then I'm going to keep repeatedly getting person objects from the stream and then looking at the count. And if the count is evenly divisible by 100, I'm going to refresh the page. So every 100 person objects that I receive, that's when I refresh the page. So this is the perfect demo to show the power of streaming and why you would use it. So let's just run the demo and then we'll look at the code. First, here's the test API that gets all 5,000 records, waits for it, and then shows them in the select. All right, so that took 2 seconds the first time. Second time, it's going to take, what, 1.4, 1.5? Okay. Now, let's clear this out and test the API stream. Now watch this. Remember, it's going to get 20 records. Boom, they're going to show up, and it's going to stream the rest. All right, that's pretty good. The first 20 records in 80 milliseconds. So it took 4.6 seconds in total, but the user didn't care because they got their list populated, as far as they know, in 80 milliseconds. Let's try it again. And this time I'm going to start scrolling. You can see it's continuously going down. I can't scroll down fast enough to keep up with it. So initial 20 and 69 milliseconds. Now let's do our gRPC. Wait for everything test. 424, 279. As it is, that's pretty fast. But watch with the stream. Boom, 47 milliseconds. And then it only took 3.7 seconds. Let's do it a second time. 20 milliseconds. That's 1 millisecond per item. And, 4 seconds for the whole thing. So here's what I learned from this exercise. It's important to use streaming. Less important to use gRPC. Okay? 68 milliseconds versus 20 milliseconds. That is significant. And again, this is all on the same machine. So add more time to it if you have to put the internet in between these things. But, it's really more important that we use streaming for perceived performance and for scalability than not. So looking at the code, starting with the API stream, we are setting up our variables here, saying loading. And now I've got my start time. I'm calling await for each on API service gEllStream. And each time I'm adding the person to my list. Now, if we reach 20, I figure out how much time that took, and I show that. And I also have to wait at least a millisecond because we're in a tight loop and we have to give the UI a chance to re-render. And then if the count is divisible by 0, I'm using the mod operator here, then I refresh the UI and show the elapsed time. So this is the pattern that I want to use, right? I want to figure out how many records does it take to satisfy my user so that they see an immediate result. And then, I can update after 100, 200, whatever you think is good. Remember, the more often you do this, the longer it's going to take. Let's look in gRPC. So again, just like before, we have our gEllStream from the people client, and that returns this async server streaming call. We iterate through it using response stream move next, and it's the same logic. If we have 20, we refresh the page, and if it's divisible by 100, we also refresh the page. And when we're done, we show the elapsed time. So that's it. So it's really about managing the user's expectations. Okay, that's what this code does. And that's my demo. Now back to you in the studio, Carl. Now, I don't know about you, but I'm planning on changing all of my API endpoints that return enumerables to streams. gRPC adds a bit more performance, but it's not that big a difference. The important thing is to stream. Hey, thanks for riding the rails with me today. This is where I jump off. I'll see you next time. Blaze a trail.